Welcome to our lecture online. Here we're having more of a visual perspective of what a line integral is. So let's say that we have a surface, and the surface you can see that it kind of goes up, then it goes below the xy plane, comes back over the xy plane like this. And let's say that we want to integrate along a line on the edge of that surface. Now what we're actually going to get, and that's really the key to this kind of line integral, if we have a scalar field and we're going to integrate along a line, or better yet, a curve along the surface of that surface that's defined by some variables x and y. So the height, perhaps in the z direction, is a function of the position in the x and y plane. Then if we integrate along the surface of that surface defined by this function, we will get an area underneath that. Think of it almost like a curtain that hangs down from the path along that we take. So we have a positive area here, we have a negative area here, we have a positive area again. And so if we're going to integrate from this location, let's say from point A to point B, along the curve like this, we're in essence going to get the area underneath the curve to the xy plane as defined by the surface. And notice we will have areas where we have positive area, negative area, and positive area. Another way of looking at it is, let's say here we have a different surface. It kind of goes down from a particular initial height here on the z. This is the, let's put some labels on there. This is the z-axis, the x-axis, and the y-axis. So you can see that starting from the xz plane at the particular height right here, we come on down along the surface until the surface goes down to zero height relative to the xy plane. If we now assume that we're going to integrate along this path right here, or this curve, or this line as we call it, then that integral will then give us the area underneath that line relative to where the surface is down to where the xy plane is. So the integral, as we call the line integral, along the curve of the function f of x along the small little ds, so what we then call a small little segment here, that would be called a small little ds. And we integrate all those little pieces, in other words, all the little heights, and we'll get the area underneath that curve. Another way of writing the integral is going from a to b along the function, and sometimes what we do is we parameterize the function. Instead of calling it in terms of x and y, we can call it in terms of r, or the cosine of an angle, or something like that. And then we multiply that function relative to a different variable, and then of course we need to multiply that times the derivative of that, and you'll see some examples of how that works later. So in essence, when we take a line integral across a surface, what we end up is the area underneath that line, or underneath the curve, and basically it's the area of the curtain hanging down from that line, if you want to think about it, down to the xy plane. And there's some good examples to get a feel of what a line integral is.